Imagine you're sitting on a train watching the world blur by outside your window. The train picks up speed faster and faster until the landscape becomes a streak of color. Now imagine someone standing on the platform watching your train rocket past. To you, the world is moving. To them, you are. But what if I told you that this simple difference in perspective holds the key to one of the most mind-bending discoveries in all of science? Welcome to the world of relativity, Einstein's revolutionary insight that forever changed our understanding of space, time, and the universe itself. Let's start with a question that puzzled scientists for centuries. Is there an absolute now that everyone, everywhere experiences at the same time? Before Einstein, most people, including the greatest minds in physics, believed the answer was yes. Time was thought to tick at the same rate for everyone, like a cosmic metronome keeping the universe in sync. But in 1905, a young patent clerk named Albert Einstein shattered that assumption with a single elegant idea. The laws of physics are the same for everyone, no matter how fast they're moving, and the speed of light is always constant. This might sound simple, but its consequences are profound. If the speed of light is always the same, then something else has to give. That something is our very notion of time and space. According to Einstein's special theory of relativity, time can stretch or shrink depending on how fast you're moving. Space itself can contract. Events that seem simultaneous to one observer might happen at different times for another. In other words, there is no universal now, only a patchwork of perspectives, each as valid as the next. Let's make this concrete. Imagine two twins, Alice and Bob. Alice stays on Earth, while Bob boards a spaceship and travels close to the speed of light. When Bob returns, he finds that Alice has aged much more than he has. This isn't science fiction, it's a real effect called time dilation, and it's been confirmed by experiments with fast-moving particles and even with precise atomic clocks on airplanes. The faster you move, the slower your clock ticks compared to someone at rest. At everyday speeds, the difference is tiny, but as you approach the speed of light, it becomes dramatic. But relativity doesn't stop there. In 1915, Einstein took his ideas a step further with the general theory of relativity, which describes how gravity works. For centuries, gravity was seen as a mysterious force pulling objects together. Newton imagined it as an invisible hand reaching across space. But Einstein saw something deeper. Gravity is the warping of space and time itself. Massive objects like the Sun or Earth bend the fabric of space-time, creating curves that other objects follow. This is why planets orbit the Sun, why apples fall from trees, and why light itself can be bent by gravity. Picture a trampoline with a heavy bowling ball in the center. If you roll a marble across the surface, it curves around the ball, following the dip in the fabric. That's how gravity works in Einstein's universe. Not as a force, but as the geometry of space-time. The more massive the object, the deeper the curve. This idea was so radical that even Einstein wasn't sure it would hold up. But in 1919, during a solar eclipse, astronomers observed starlight bending around the Sun, just as Einstein predicted. Overnight, he became a global celebrity, and relativity became the new foundation of physics. So, what does all this mean for you? For one thing, it means that space and time are not fixed, absolute things. They are flexible, dynamic, and interconnected. Your experience of time depends on how fast you're moving and how close you are to massive objects. GPS satellites, for example, have to account for both special and general relativity to give you accurate directions. Without Einstein's equations, your phone's map would be off by miles. But relativity also invites us to see the universe in a new light. It tells us that reality is not as simple as it seems, that our everyday intuitions can be misleading, and that the cosmos is full of surprises. Black holes, for instance, are regions where gravity is so strong that not even light can escape. They are the ultimate test of Einstein's ideas, and they continue to challenge our understanding of physics. And yet, for all its strangeness, relativity is grounded in simple, everyday experiences. The next time you see a train speeding by, or watch the stars twinkle in the night sky, remember that you are witnessing the dance of space and time, the interplay of motion and gravity, the legacy of a young man who dared to question the obvious. Einstein's genius was not just in solving equations, but in asking the right questions. What if time is not absolute? What if gravity is not a force but a curve in space-time? By following these questions to their logical conclusion, he unlocked secrets that had eluded humanity for millennia. And the best part, you don't need a PhD to appreciate the beauty of relativity. All you need is a willingness to look at the world with fresh eyes, to imagine what might be possible, and to embrace the wonder of discovery. Let's dig deeper into the everyday consequences of Einstein's relativity, because while the ideas may sound abstract, Their fingerprints are all over our modern world. Take, for example, the GPS system that guides millions of people every day. Each GPS satellite orbits Earth at thousands of miles per hour, and at an altitude where gravity is weaker than on the surface. According to special relativity, the satellite's high speed makes their onboard clocks tick slightly slower than clocks on Earth. But general relativity tells us that being farther from Earth's mass where gravity is weaker makes those same clocks tick faster. The two effects work in opposite directions, but both are real and measurable. If engineers ignored relativity, your GPS would be off by about 10 kilometers every day. Thanks to Einstein, your phone can pinpoint your location to within a few meters. But relativity's reach goes even further. Consider the life of a cosmic ray, a high-energy particle born in a distant supernova, hurtling toward Earth at nearly the speed of light. As it slams into our atmosphere, it creates a shower of new particles called muons. These muons are unstable. At rest, they decay in microseconds, far too quickly to reach the ground. Yet, because they're moving so fast, time slows down for them, and they survive long enough to be detected at the surface. This is time dilation in action. Not in a lab, but in the sky above your head, every moment of every day. Relativity also changes the way we think about light and energy. Einstein's most famous equation, EMC tells us that mass and energy are two sides of the same coin. A tiny amount of mass can be converted into a tremendous amount of energy, a principle that powers the sun, fuels nuclear reactors, and tragically unleashed the destructive force of atomic bombs. The sun shines because hydrogen atoms fuse into helium, releasing energy as their combined mass decreases. Every sunrise is a daily reminder of relativity at work. But perhaps the most mind-bending consequence of relativity is the way it reshapes our understanding of the universe itself. In Einstein's view, the cosmos is not a static stage, but a dynamic, evolving entity. Space can stretch and bend, time can speed up or slow down. The universe itself is expanding, as galaxies race away from each other in the aftermath of the Big Bang. Black holes warp space-time so severely that they create event horizons, boundaries beyond which nothing, not even light, can escape. And at the center of every black hole, according to Einstein's equations, lies a singularity, a point where the known laws of physics break down. These ideas are not just theoretical. In 2019, astronomers captured the first ever image of a black hole's shadow, using a network of telescopes spread across the globe. The image confirmed Einstein's predictions to an astonishing degree of accuracy, more than a century after he first described them. Gravitational waves, ripples in space-time caused by massive objects like merging black holes, were first detected in 2015, another triumph for general relativity. Each new discovery is a testament to the power and resilience of Einstein's ideas. Yet, for all its successes, relativity is not the final word in physics. At the smallest scales, where quantum mechanics reigns, the smooth fabric of space-time gives way to a jittery, probabilistic world. Gravity, as described by Einstein, doesn't quite fit with the quantum rules that govern atoms and particles. Physicists are still searching for a theory that unites these two pillars, a theory of everything that can explain both the cosmic and the quantum. But even as we search for answers, relativity remains our best guide to the workings of the universe on the largest scales. Let's return to the human side of the story. Einstein's journey was not just one of equations and experiments, but of imagination and courage. He dared to question the most basic assumptions about space and time, and he followed the logic wherever it led, even when it defied common sense. His work reminds us that science is not just about memorizing facts, but about challenging the obvious, embracing uncertainty, and seeing the world with new eyes. And relativity is not just for physicists. Its lessons are for all of us. It teaches us that perspective matters, that what you see depends on where you stand and how you move. It reminds us that the universe is more flexible and surprising than we might think, and that our place in it is both humbling and exhilarating. The next time you look at your watch or use your phone or gaze up at the stars, remember that you are living in a world shaped by Einstein's insights. So, how can you experience relativity for yourself? While you may not be able to travel near the speed of light or visit a black hole, you can perform simple thought experiments, the same kind that Einstein used to unlock the secrets of the universe. Imagine riding a beam of light, or watching two lightning bolts strike a moving train at the same time. Picture the fabric of space stretching and curving around massive objects. These mental journeys are the first step toward understanding the true nature of reality. In the end, relativity is more than a set of equations. It's a new way of seeing, a lens that reveals the hidden connections between space, time, energy, and matter. It's a story of curiosity, creativity, and the relentless pursuit of truth. And it's a reminder that, in the words of Einstein himself, the most beautiful thing we can experience is the mysterious, It is the source of all true art and science. Let's take a moment to appreciate just how radical Einstein's ideas were, and how they continue to shape our world even a century later. Before Einstein, the universe was thought to be a vast, unchanging stage, with time ticking away the same for everyone, everywhere. Newton's laws had ruled for centuries, and the idea that space and time could be anything but absolute seemed unthinkable. But Einstein's relativity shattered those certainties, revealing a universe that is dynamic, interconnected, and far stranger than anyone had imagined. One of the most astonishing predictions of general relativity is the existence of black holes, regions of space where gravity is so intense that nothing, not even light, can escape. For decades, black holes were considered mathematical curiosities, too bizarre to exist in reality. But as astronomers peered deeper into the cosmos, evidence began to mount. Today we know that black holes are not only real, but common. They lurk at the centers of galaxies, including our own Milky Way, and they play a crucial role in shaping the evolution of the universe. Black holes are the ultimate test of relativity. When two black holes spiral together and merge, they send out gravitational waves, ripples in the fabric of space-time itself. These waves travel across the universe, carrying information about the most violent events in nature. In 2015, scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, detected these waves for the first time, confirming a prediction Einstein made 100 years earlier. The signal lasted just a fraction of a second, but it opened a new window on the universe, allowing us to hear the collisions of black holes billions of light years away. But relativity's reach extends far beyond the exotic and the extreme. It touches our daily lives in ways we rarely notice. The very concept of simultaneity, of two events happening at the same time, depends on your frame of reference. Imagine two lightning bolts striking opposite ends of a moving train. To someone standing on the ground, the bolts might appear to strike simultaneously, but to a passenger on the train, one bolt might seem to strike before the other. Both perspectives are correct, according to relativity. There is no absolute now, only a web of events, each connected by the speed of light. This idea has profound implications for our understanding of causality and the flow of time. In Einstein's universe, the past, present, and future are not rigidly separated, but woven together in a four-dimensional fabric called space-time. Events that are now for one observer may be in the past or future for another. This leads to the famous twin paradox, where one twin travels at near light speed and returns younger than their sibling. It also raises deep questions about the nature of time itself. Is the future already written, or do we create it as we go? Relativity also challenges our intuitions about energy and mass. Einstein's equation EC tells us that mass can be converted into energy and vice versa. This principle underlies the power of nuclear reactions both in stars and in human technology. It also means that the energy of motion, kinetic energy, adds to the mass of an object. As you accelerate an object to higher and higher speeds, its mass increases, making it harder and harder to go faster. This is why nothing with mass can ever reach the speed of light. It would require infinite energy. But perhaps the most profound lesson of relativity is that the universe is not as it seems. Our everyday experience is just a tiny slice of a much larger, more mysterious reality. Space and time are not fixed backgrounds, but active participants in the cosmic drama. Gravity is not a force, but a manifestation of geometry. Light is not just a wave or a particle, but something that transcends our categories. And the act of observation itself can shape the outcome of events. Einstein's insights have inspired generations of scientists, artists, and thinkers. They have led to new technologies, from GPS to nuclear power, and to new ways of seeing the world. But they have also raised new questions about the origins of the universe, the fate of black holes, and the ultimate nature of reality. Today, physicists are searching for a theory that unites relativity with quantum mechanics, a quest that may one day reveal even deeper secrets. Yet, for all its complexity, relativity remains grounded in simple, powerful ideas. The speed of light is the same for everyone. The laws of physics are universal. Space and time are flexible, not fixed. These principles are as true for a child riding a bicycle as for a photon racing across the cosmos. They remind us that the universe is accessible to anyone with curiosity and imagination. So the next time you look up at the night sky, remember that you are seeing the universe through Einstein's eyes. The light from distant stars has traveled for millions of years, curving around massive objects, stretching as the universe expands. The GPS in your phone is a daily testament to the reality of relativity, and the very fabric of space and time is alive with possibility, waiting to be explored. Einstein once said, "Imagination is more important than knowledge." For knowledge is limited, whereas imagination embraces the entire world. Relativity is the ultimate expression of that spirit, a theory born not just of calculation, but of wonder. It invites us all to see the world anew, to question the obvious, and to unlock the secrets of the cosmos. As we reach the end of our journey through Einstein's world, let's pause to appreciate just how much has changed because one person dared to ask, what if? Relativity isn't just a set of equations or a chapter in a physics textbook. It's a new lens for seeing the universe, a reminder that reality is richer and more surprising than our senses alone can reveal. Einstein's insights have transformed not only science, but the way we think about time, space, and our own place in the cosmos. Think about it. Every time you use your phone's GPS, you're relying on satellites that must account for both special and general relativity to keep your location accurate. When you look at the stars, you're seeing light that is bent and stretched across the fabric of space-time, shaped by the gravity of everything it has passed. The very atoms in your body, forged in the hearts of stars, owe their existence to the interplay of mass and energy that Einstein described. His work touches every corner of our lives, often in ways we don't even notice. But perhaps the greatest gift of relativity is the sense of wonder it inspires. It shows us that the universe is not a static, predictable machine, but a living, evolving tapestry, one where the rules can change depending on your perspective, and where the impossible becomes possible. It reminds us that the boundaries of knowledge are always moving, and that the next great discovery could come from anyone, anywhere, who is willing to look at the world with fresh eyes. Einstein's story is a testament to the power of curiosity and imagination. He wasn't a superstar student or a privileged academic. He was a patent clerk who loved to think deeply about simple questions. His willingness to challenge the obvious, to follow the logic wherever it led, changed the course of history, and his legacy lives on in every scientist, student, and dreamer who dares to ask why. So, as you go about your day, remember that you are part of this grand adventure. The universe is still full of mysteries, and the tools to explore them are within your reach. Whether you're gazing at the stars, experimenting in your kitchen, or simply wondering about the nature of time, you are carrying forward the spirit of discovery that Einstein embodied. Relativity may have unlocked some of the universe's deepest secrets, but it also opened the door to new questions, new possibilities, and new dreams. The journey is far from over. Keep asking, keep exploring, and never stop marveling at the beauty and strangeness of the world around you, because in the end, the greatest secret of all is that the universe is yours to discover.